Assalamualaikum and good day, sir. We are from group number 10. Today, Ummi, Shan, and Aidil are going to present about our lab simulations of BJT biocircuit and diode application circuit. First, I will explain about CE configurations. What is CE configuration? CE configurations is common enter. Why these circuits name CE configurations? Because the resistor over here is exist. Next, all the data given here is based on our previous assignment, which is VCC1, VCC2 is given as 25 volt. This is the DC voltage. RB 510 kilo ohms, which is standard value RB. SC also standard value 1.8 kilo ohm. RE also standard value 620 ohm. Okay, over here, transistor is NPN transistor with the beta 130. Basically, we need to know VB, VE over here, and VC over here is must point at ground, over here ground. Meanwhile, for VCEQ, we only point at its transistor. We want to know the voltage at its transistor. So that's why you can look here, reference 1 and reference 2. For reference 1 is for VB, VE, and VC. For VCEQ, for reference number 2. Then I'm going to put our current. We want to know the current for this circuit and this current for IC. Then we run our simulation. So this is the value, which is for previous value. It's not far away. This is for our previous assignment that we are manually calculated. IB 38.46 microampere, RC 1.8 kilo ohm, VCE. Okay, this VCE with 12.5 volt is same with VCEQ. So you can see VCEQ over here. VCEQ, this VCEQ is same with the VC. Okay, but the value is a little bit different. Our previous calculations, we got 12.5. Meanwhile, for the lab simulation, we got 12.107. Really, it's not far away from our simulation, so we assume that our circuit is acceptable.
Now I will proceed the simulation for question 2, positive cycle of clamper. As given in question, the input voltage is positive 35 volt, and then the output we should get positive 10.3 watt. So we will construct the circuit. Here the DC voltage, this one, 35 volt, same as given in question, and then the capacitor 1 microfarad, and then it will enter a silicon diode 0.7, and then a battery 59 watt, and then a resistor 110 kilo ohm. So when it be run, it will get 10.3 watt. For positive cycle, the silicon diode will be short circuit, so it will flow, the current will flow through the capacitor and then enter resistor. So here will be the current flow direction. So this one will be open circuit. But even we draw here, it doesn't matter, we still get 10.3 watt because here will be short circuit, it won't be run through here. So we try to delete this and we rerun again, and it get exactly the same 10.3 watt. So the current will flow here. For the simulation, it's the same exactly as the theory calculation.
Let's proceed to the next cycle, which is the negative cycle. The input will be negative 35 volt, and we will get the value for output is negative 59.7 volt. So basically, this circuit is exactly the same as the positive cycle one, but what we change here is the polarity for DC voltage here, the Vin, to get the value for the negative 35 volt. So when we change the polarity for DC voltage here, it will make the current will go through this diode, so it won't be an open circuit here. So when we run the simulation, we'll get the value for V naught exactly like the question state, which is negative 59.7 volt. So basically everything in this simulation is exactly the same as we do in the calculation. So that's all from us. Thank you.